In this presentation, I want to talk about stochastic integer programs and LP relaxation. This presentation is based on the book by Birge 2011, chapter 7, section 1. This is the general form of stochastic program when we show the first stage by CTX, and this is the constraint for the first stage, and all of the second stage is squeezed over here. I mean, this delta x is basically the expectation. When we get the expectation from the second stage function shown by the qx, it is shown by delta. What is the qx itself? The coefficients of the y in the objective function. We will try to minimize that, and we have the constraints for the second stage over here, coefficients of the y, x, and the constant. And we say y belongs to the set of y, and this set of y is considered to be integers. How we can relax that set of y? Let's say that in that integer programming we are working with is considered as binary. So we are working with a specific case of that, and we can say the set of y, it can be like 0 and 1, and we have n m y's, and every y has 2 dimensions. Y bar represents the relaxation of the y, and I can say instead of 0 or 1, y is between 0 and e. What is e? E is the upper bound presented here. When the qxi represents the main the second stage problem, and in the second stage y belongs to the y set, if I relax this problem by replacing y with y bar, when y is not binary anymore and it is between 0 and 1, I can show it by C. So C is the LP relaxation of the Q. If you can remember, when I get expectation from the Q, I show it by delta. If I get expectation from C, I'm gonna show it by CX. All of these are some backgrounds for the proposition 1. In chapter 3 of birge, we are talking about linear stochastic problems, and in the L-shaped solution methods, as part of L-shaped solution methods, we introduce these optimality cuts. Coming back to C and Q, C is integer, Q is Q is linear. Obviously, C is less than Q. If we get expectation from C and Q, again, the result of expectation should be less than that. Let's also bring that cuts of theta, and the other parts of that. We can say E minus EX is less than CX, which is the integer part, and so this is the relaxation part, integer part, and theta.